So for this example, we're going to find an angle theta that's between 0 and 360 degrees that has the same sine value as 230 degrees and the same cosine value as 230 degrees. So this problem depends on our understanding of reference angles and also our understanding of how sine and cosine values have repeats based on the quadrant we're in. Okay, so first let's talk about reference angles. So when we're talking about an angle, the reference angle makes up the terminal side and the x-axis. So if we have an angle in the first quadrant, like let's say that's the angle, okay? Then the angle that makes up from this side to the x-axis, that's the reference angle. So if the angle is actually in the first quadrant, it's the angle itself. So here, let's just say this is 60 degrees. Then in the second quadrant, let's say our angle went all the way from here into the second quadrant. Let's say it looks like that. The reference angle then in the second quadrant makes up from the terminal side to the x-axis. So it's this angle right here. I tried to draw them the same. Let's just go ahead and say it's also 60 degrees. Okay, so these two both have reference angles of 60 degrees in quadrants 1 and 2. Now, what's cool about this is that if you were to take the sine value of the first angle, this red angle right here, okay, it's going to happen to equal the sine value of this green angle right here. Why? Because it's the same reference angle and sine has the same positive value in the first and second quadrant, because remember, sine is related to the y-axis. So we kind of pair sine with y values. That comes from the definition of sine being, sine of an angle equaling y over r. Okay, so we're pairing sine up with y values. So when the y values are positive, sine is positive. So if I had happened to look at reference angles in quadrants 3 and 4, so in quadrants 3 and 4, let's say we're looking at an angle, from here to here. Okay, that means we're looking at this reference angle right here from that end terminal side to the x-axis. So let's say, again, it's 60 degrees. Then that would have the same sine value as a reference angle based on this angle over here. And that would be, by the way, the angle that went all the way from here to here. Okay, so these two would have the same sine value because they're both in quadrants 3 and 4. And in quadrants 3 and 4, our y values are negative. So these two would have the same exact sine value of those two angles. Okay, so if we kind of build on that idea, let's do this specific problem. So 230 degrees, 230 degrees. So we're going to draw that out. We'll start from the x-axis. So 180 goes right here. So 230 is going to land us somewhere in quadrant 3. All right. So I need to find the reference angle then from this side to the x-axis. So what I'll do is I'll basically take 230 and I will subtract 180. And that's going to leave me with 50 degrees. So that's my reference angle here in this quadrant, 50 degrees. So we're talking about the sine value. Sine, because it's going to be negative in quadrant 3, we want to find the other place where sine is negative. And I just kind of finished saying it, but that would be in quadrant 4, because this is where all the y values happen to be negative. So if I come over here into quadrant 4 and look at the same reference angle here, 50 degrees, what I'd like to find, what I'm after, is figuring out what this actual total angle is in quadrant 4 from the start of the x-axis all the way around. Okay, so to figure that out, I will take, since it's just a little bit short, I'll take 360 and subtract 50, and that'll give me 310 degrees. So it will have the same value at 230 as it does at 310 degrees because their reference angles matches and the sine is negative in both of those quadrants. Okay, so we're going to do the same thing, but we're going to do it for cosine. So for cosine, again, we're still going to be looking at the same angle, which I already know is in quadrant 3, and I already know has a reference angle value of 50. But cosine, we connect to the x values. That's because we think of cosine as x over r. So it's the x connection this time. So the x values in quadrant 3 are still negative. Okay, so now we're looking at the x-axis instead. So look in here. All right, so where else are cosine values negative? That will be in quadrant 2, right above it. So up here in quadrant 2, I want to draw my reference angle, 50 degrees. But what I'm really after is this angle right here, all the way into quadrant 2. So to figure that out, I'm going to take 180 degrees and subtract 50, which will give me 130 degrees. So cosine is going to have the same value at 130 degrees as it does at 230 degrees.